Good morning to everyone. I'm Dr. Sumi MS. The name of the course is C Programming and Data Structures, and today's lecture topic is hashing from Unit 4 Nonlinear Data Structures. On completion, the students will be able to explain the technique of hashing and define what a hash table is and insert elements in the hash table. Hashing in the data structure is a technique of mapping a large chunk of data into small tables using a hashing function. It is also known as message digest function. It is a technique that uniquely identifies a specific item from a collection of similar items. It uses hash tables to store data in an array format. Each value in the array has been assigned a unique index number. Hash tables use a technique to generate these unique index numbers for each value that is stored in the array format. This technique is called as hash technique. Hashing in the data structure uses hash tables to store the key value pairs. The hash table then uses a hash function to generate an index. Hashing uses this unique index to perform insert, update as well as search operation. The data are stored in an array format. These data have their own index value, and if the index value is known, then the process of assessing the data becomes easier and quicker. Separate chaining. Separate chaining is the collision resolution technique that is implemented using a linked list. When two or more elements are hashed to the same location, then these elements can be represented in a singly linked list format. Since this method uses extra memory to resolve the collision, it is also known as open hashing. In separate chaining hash table, each slot of the hash table is a linked list. We can insert the element into the specific linked list to store it in the hash table. If there is any collision, that is, if more than one element after calculating the hashed value mapped to the same key, then these elements are stored in the same linked list. So here the element at index 2 has two elements here, and they are stored as a singly linked list. Example for separate chaining. Let us understand this with the help of an example, and given below is a hash function, and the hash key is obtained as key modulo divided by the table size. So here in a hash table with size 7, the keys 42 and 38 would get a remainder 0 and 3 respectively, and hence they can be stored in the position of index 0 and 3. So if now we are inserting a new element 52, which also produces a remainder of 3 when divided with the table size 7, then the element 52 has to be inserted in the slot 3. So it is inserted along with 38 in a singly linked list in slot 3. So the separate chaining method handles the collision by creating a linked list to the occupied buckets. It is important to choose a good hash function in order to minimize the number of collisions so that all the key values are distributed evenly in the hash table. Some characteristics of good hash function are: it would minimize collisions, it is easy and quick to compute, and the key values inserted evenly in the hash table with the help of linked list, and also they have a high load factor for a given set of keys. Quiz questions on hashing. Insert the elements in the hash table by using separate chaining as the collision resolution technique for the given hash function key modulo divided by 6, and 6 elements to be inserted are 14, 77, 55, 89, 32 and 73. Thank you.